All right, Harmony Science Academy students, specifically honors geometry students, let's go ahead and get into this. Pencil, notebook, calculator, Chromebook. And again, Zig Ziglar's saying basically says, hey, if you want something, you're going to get it, right? If you want to learn, nothing can stop you. If you don't, you're probably going to be blaming all sorts of other people and reasons and things, okay? So don't forget, as you guys are recording, to get the title, the objective, okay? The vocabulary, I'll have something specific for you guys. As a matter of fact, let's see here. At the very minimum, let's have you look up two words: simplify on Google and radical. Okay? You'll see why in a little bit, but yeah, right here you want to pause the video, go to Google and just get that vocabulary. Okay? We're talking honors geometry. Alright, so as far as the title, it's Algebra Review, okay, in your notebooks. As far as the objective, there's a couple, but this is the one of them, solve equation, and the other one is simplify radicals, okay, or simplify. Alright, so let's, there's really five types of problems, so let's go ahead and do one of each, okay? Alright, so let me get some ink, and we're ready to go. Alright, so let's go ahead and solve this equation. So this is very basic Algebra 1 material. Okay, hopefully you guys are solid. So let's look at, let's say 2. Okay. A lot of this is just simplifying, making it simpler. So here I have 6n minus 6 plus 2 equals 14. On your paper, you guys will write to the problem and then begin to solve it, okay? So here, the next step would be what? 6n minus 6 plus 2 is minus 4 equals 14. And after that, you want to add 4 to both sides. So we have 6n equals 18. And you want to divide both sides by 6, which gives you 3. And that's pretty much it, okay? So you've got different scenarios to look at, but that's the idea with those, okay? Next up, simplify. Simplify radicals. Radicals are important because they pop up a lot in geometry and pretty much in all your advanced classes beyond Algebra 1. So let's go and review what you should have been taught last year. And I'm going to show you a method that works all the time. There's other tricks for special cases, but I want you guys to be able to do these anytime, all the time, okay? So to simplify, we've got to make this simpler, right? Something we can understand a little simple, a little more simpler, okay? So what you want to do is take all the small numbers, all the prime numbers that divide 150. For example, 2 goes into 150 times 75, okay? Now 75 is 3 times 25, and 25 is 5 times 5. Okay? If you're fast at it, good. If you're not, you might just have to go slower, okay? Some of you guys might actually have to do something like this, right? Like 150, which is 2 times 75. 75 is 3 times 25, and then 25 is 5 times 5. Okay, so every time that you're done, you circle it so you don't lose them. Okay, and these numbers go in here. Okay, now what you do here is you're going to circle every pair. Okay, think of it this way: 5 times 5 is 25, and the square root of 25 is 5. So this trick works even when you're not too sure. So what happens is you've got the 7 already outside the radical. Now, out of this pair, 1 comes outside. Okay, outside the radical. So you can cross it off, and then you write what's left inside, 2 times 3. And since there's no more pairs, you just can take care of the multiplication. 7 times 5 on the outside is 35, and inside is square root of 6. Okay. All right, that's how you simplify radicals. Now let's take a look at this situation here where we're adding or subtracting radicals, okay? Now this one and this one are pretty easy, okay? These are a little tougher, so let's go ahead and do one of them, okay? Now, Again, we just talked about simplifying, so in this case, notice I have square root of 20. So what I can do is I can take the 20, okay? Oops, excuse me. And I know that the trick is to take out all these prime factors. So 2 times 10, 10 is 2 times 5, right there, okay? So, and this equals, because there's a pair, it's 2 square root of 5, okay? So I'm doing it fast. Again, this is algebra review, so hopefully you can do it as fast. If not, go a little slower, okay? So I'm going to rewrite these as 3, negative 3 times 2 square root of 5. Okay, this is now this, right? We just talked about that. Plus 2 times 2 square root of 5 plus 2 square root of 2. Okay. Now the reason you have to do it this way, some of you guys may be like, I can just do it this way. Sometimes when you simplify like this, you'll realize that this may have had a square root of 2, which means you could combine it like that. It's kind of hard to tell, so that's why you simplify so that you can know for sure. Okay. So now I'm going to multiply negative 3 times 2 and 2 times 2, so I get negative 6 square root of 5 plus 4 square root of 5 plus 2 square root of 2. Now this one and this one have a square root of 5, so I can take the negative 6 plus 4 and I get negative 2 square root of 5. And since he's got a square root of 2, I can't combine him. He stays by himself still. Okay? Alright. So that's how you add or subtract. Okay? Radicals. Now as far as these over here go, we're going to have to multiply. Okay? Notice the difference. Here I couldn't combine these square root of 5 and square root of 2 because I was adding or subtracting. Here, okay, I can. Right? I can just multiply those two. I'm going to do 21 just because it's a little looks a little tougher. Okay? Or I guess I'll just jump to 22 here real quick. Okay. So pay attention to the important part is this. Okay. Is because I am multiplying square root of 15 times square root of this, I can join them under the radical. 15 times 3 plus, whoops, I distribute it. And let's see here. If I multiply this times this, he doesn't have a radical, so it's the 3. It's a 3 times the square root of 15. Okay? Now that I've distributed, and again, radicals, you want to get really good at them, again, because you're going to see them a lot in geometry and moving forward, okay? So now this, what does this become? This becomes 45 plus 3 square root of 15, okay? All right. Now, what can we do here, okay? In this case, there's not much we can do. How can we check? Let's take 45 and break it up into its prime factors, okay? That equals 5 times 9, and 9 is 3 times 3. So again, since that's a pair, we can kick one out, and we have 3 square root of 5. So here I can write this as 3 square root of 5 plus, let me see if I can do something with 15, okay? This is like scratch work. 15 equals 3 times 5. There's no pair here, so nobody pops out the radical. So it has to stay like that. So in this case, we have 3 square root of 15. Okay? Now, if you're looking at this and thinking, well, the 3's match, no. What has to match is what's underneath the radical. That's a 5, that's a 15. It doesn't match, so we're done with that. Okay? So that was multiplying. Last, are these situations, guys, where you have to divide by a radical. It looks very scary, it should, but there's a quick fix. The only problem with this is you can't have a radical in the denominator on the bottom. So here's the easy fix. Multiply the top and the bottom by square root of 7. Okay, why? Because something divided by itself is 1. So anything times 1 is itself. So I'm not changing nothing, but it's going to look different so that we satisfy what they want. Okay. So when I multiply this and this, I get 2. And inside the radical, 6 times 7 is 42. Okay. Here, I now get 49, or 7 times 7, right? I get this 7 and the 7. Why am I not writing it as a 49? Because it's a pair. Which means that when you find a pair in the radical, it pops out of the radical. Nothing's left, so I don't put a radical here. And I'm left with 2 square root of, 2 square root of 42. Okay, so that's it. I'm done. The only thing is you want to get really good at simplifying this. So let's see if I can break this down further. But I'm pretty much done with the important part. Okay, let me just look at square root of 42. And I'm doing this more so you guys can also see a little more example. This one is 2 times 21. 21 is 3 times 7. And that's it. And guess what? There's no pairs in there. So this, I'm going to leave it like this. So this is my final answer. If there was pairs, then I deal with them. Okay. All right, guys. Go and again take these notes down, and then we'll do some together as a class and let you guys work alone. Okay. Catch you in class.